Hello friends, welcome back. So we just discussed about emission inventory, and now we will discuss about air pollution control and mitigation measures, right? So in air pollution control, basically we will see about different devices or methods which are used for controlling the air pollution, and it will depend upon what kind of source it is, like stationary source or within stationary source, then whether particulate pollutants are to be controlled or gaseous pollutants are to be controlled. So accordingly devices will vary. Like for particulate matter, we have to use settling chambers or cyclones, fabric filters, bag house filters, or electrostatic precipitators. Whereas in gaseous air pollutants, when we want to control, then there are certain mechanisms like absorption, adsorption, or biofiltration. Based on those mechanisms, there are certain methods or devices which are used for controlling these gaseous air pollutants. Also, like scrubbers or those kind of things we will discuss. Then if you want to control the air pollution emissions from mobile sources, then different methodologies are there, like exhaust gas recirculation or the air injection system, okay, catalytic converters, which all of you know, we in our cars and vehicles we use this quite frequently. And then we will conclude, and after that we will see these mitigation measures. Okay, so when we talk about air pollution control, basically there are several sources of air pollution. As you know, it can be natural, like volcanic eruptions or sandstorms or forest fires, all those natural ways of the air pollution. But man-made pollution or anthropogenic pollution emissions are from industries, transportation sector, domestic sectors, which we just discussed during emission inventory development related lecture. So those human activities based sources we can control basically. Okay, those are the sources, the emissions from which we can easily control, and the devices, the methodologies we will discuss focused on those particular sources, right? Now if you talk about how to control, so basically when we talk about the controlling mechanism, then we have to see different kind of possibilities. Like maybe we can change the raw material, right? We can change the process, we can change some methodology, all these we can change some equipment. So in this production line or process line, whatever methodologies are there, that can be seen, and we can apply those principles which can control or mitigate the air pollution emissions. Well, when we talk about particulate pollution from stationary sources like chimneys or stacks in power plants or other industrial kind of setup, then there are several kind of devices or equipment like settling chambers or inertial separators, cyclones, scrubbers, electrostatic precipitators, fabric filters. These are the mostly popular kind of devices which are mostly used in these kind of industries. So if we talk about gaseous pollutants, then spray towers or pack towers, venturi scrubbers, some adsorbent units that can be used from mobile sources, as I said, catalytic converters kind of things we can use. When we talk about settling chamber, this is the most simplest device or equipment. That's a kind of chamber, okay, like a room, and one inlet is there where this dirty gas or exhaust emission is entering, and then outlet is there. So basically what we look into that, this distance, horizontal distance, when this gaseous emission is coming from this particular point to this point, so the time which is taken in horizontal movement, the same time should be taken, or less time should be taken by the particulate matter to settle down vertically due to gravity. So that kind of design we have to really take care. That is the fundamental thing. We need to use this particular thing, like velocity of the gas and velocity of the particles. So those things are the governing parameters of the design of these settling chambers, and they are very simple, but they need lot of space. That's why it's not much popular. Plus they are only those coarse particles can be removed, not the fine particles. Fine particles will short circuit, directly through this path. Although one can have different trays and different kind of combinations can be developed and incorporated in the settling chamber also, but still this is the something which is being used like for pre-cleaning purpose. Otherwise it is not much used, because only above 40 micrometer in diameter particles can be removed easily. Otherwise fine particles will just go with the exhaust emissions basically. And as it is written, widely used as pre-cleaners, because when we want to use some sophisticated devices, for that if you want to reduce the pollution load, so better you first pass through this settling chamber, so that coarser particles get settled and fine particles can be removed by that particular sophisticated device. There are advantages and disadvantages. Like low cost, it is very maintenance free almost. No skilled personnel are needed for operating this kind of device, and continuously it can be used for dry those solid particles, and it can be constructed with any kind of material, whether steel or other kind of material, etc. It can vary. The temperature and pressure of those exhaust gas plumes can vary depending upon the material. But there are disadvantages, because in cities land is very expensive thing, and for this lot of space is required, so this is not desirable. And then it is only good for these collection of particles which are less than 50 micrometer. Efficiently it can relatively low particle collection efficiency is there for those particles which are less in size than 50 micrometer. Otherwise 40 to 50 and above particles can easily be removed, but for lower dimensions this is not a good device. Well, when we talk about inertial separators, so those can be used by different kind of other things like baffle type or lower type separator or dust traps. You can see these are the baffle types, so that a zigzag kind of shapes are there of these plates. So impaction is there, because gas, the flow of the gas and particles will have different kind of flow parameter. So gas will pass, but those particles will hit these undulated kind of segregated staggered plates, and they will be removed. But this is good for removing particles which are larger than 20 micrometers. So you can say it is better in removing particles less than size of the 40, which was not much possible in settling chamber. But still it is not good for those particles which are less in size than the 20 micrometer. When we talk about these lower type separators, so again the change of the motion or direction, again this kind of inertia is there, impaction is there, and the particles can be removed. But again there is limitation that this kind of device removes particles larger than 30 micrometer. Okay, when we talk about dust trap, then there is a change in direction when gas is coming like this, and the outlet is on upper side, so gas goes after 180-degree turn, right? So in that particular direction change, basically this dust or particles settle down and gas goes up. So that is the, again it is good for 30 micrometer and larger size particles. Otherwise it is not much good. And these inertial separators can be used for like in power plants or rotary kilns to remove the particulate pollutants. And it is also used sometimes like the settling chamber for pre-cleaner kind of operation. There are advantages and disadvantages, like it's simple and low cost construction, of course, and operation is also simple. Low pressure drop is there, not very high pressure drop. But there are disadvantages like baffles can be clogged, okay, and this efficiency can be reduced after that. Excessive abrasion can again do because of this impaction. So abrasion is there, so again wear tear can be possible. In the cyclonic separators are there. So basically in this this rotational velocity is there, and very simple device, but due to rotational this centrifugal force is there, and particles strike to the wall of this cyclonic separator, and then they lose the velocity and they slide down and they get collected in the hopper at the bottom. So that's very simple device of this cyclone separators. And because of mass of the particles in less gas velocity and radius of the cyclone, they provide this centrifugal force, and accordingly which kind of diameter of particle, which kind of size of particle can be removed efficiently. You can play with these relationship, and you can remove very fine particles up to 10 micrometer. So up to 10 micrometer efficiency is about 90%. Larger particles can be removed more efficiently, like 95%. A particle size is 20 micrometer or more, and it can be operated at very high temperature, around 1000 degrees Celsius, 500 atmosphere pressure, and it can handle gas volumes of very wide range, like 0.85 to 700 cubic meter per minute. So that way it is a wonderful device. But if there is a leakage somehow, then this efficiency goes completely, almost it is not usable, you can say. So there are certain advantages and disadvantages. Like again, it is low initial cost in comparison to other sophisticated devices like ESPs and these electrostatic precipitators also. Well, simple in construction, low pressure drop, low maintenance, and dry collection and disposal. The variation of the temperature pressure can be handled, but efficiency is low. So disadvantage is like particles less than size of this 10 micrometer, it is not very good. Well, also collection efficiency decreases when some issues are there with the gas stream and these particles. Okay, when we talk about fabric filters, then there are baghouse filters also, they are known as. They are very good and high efficiency up to 99%, and particles up to the size range of 0.1 micrometer, okay, to 1000 micrometers. So very large range is there. So this is a wonderful device. Only problem is that for high temperature it can't be used because fire problem may be there. But different kind of fabrics are available these days, and different kind of this temperature range can be handled by this. There is principle of this pores size. So this air to cloth ratio has to be maintained to have good efficiency, and this simple equation is used for calculating air to cloth ratio. And otherwise, when these pores are clogged, then efficiency decreases, pressure drop is there. So continuously you have to clean it by vibrations, etc. Application can be in several kind of industries like metallurgy or foundries or cement industry, ceramic, floor mills, etc. It's widely used basically. There are again some advantages and disadvantages. Advantages are like very high efficiency, okay, effective wide range of the dust size, as you have seen. Dry collection and disposal is good. For moisture it is not good because clogging will happen. So disadvantages are there. It's a large size, and then it requires dry environment. Otherwise, as I said, moisture will clog these pores and the efficiency will drastically reduce. Okay. Then there are other issues also, like fire and explosion potential may be there in certain cases. So skilled manpower is needed. Wonderful, other devices there in these kind of circumstances or situation. This is ESP, electrostatic precipitator. Okay, so when particles go through certain charged area, so they get charged, okay, and then for opposite charge of the those plates, they get attracted to and then slide down and get collected into the hopper, and it can remove particles less than 10 to 20 micrometer, and very good efficiency is there. Principle is this charge based, but there may be some issues because sometimes like ozone formation may be there, and high voltage equipments are used, so skilled manpower is needed. Those kind of issues are there. Particles as small as 0.1 micrometer can easily be removed. So that way it is a wonderful device, and for several power plants, etc., it is used very much, but initial cost is very high basically. So small scale industries can't afford, and as I said, it can have some issues with ozone kind of, and some explosion hazards may also be there if it is not operated properly. Then there is wet scrubber, which can be used to remove the particles as well as gaseous pollutants, because it scrubs through absorption in liquid, some sort of this absorbent we are using in this particular device, and you can see several kind of features are there. And this can be cyclone scrubber, simple scrubber can be there, spray tower or fixed throat venturi scrubber can be there. So different kind of spray towers and scrubbers can be used depending upon the situation. There are advantages because it can handle even high temperature gases, because it is using liquid. You can use some liquid of with some chemical or simple water also, depending upon the requirement. Relatively low maintenance, and it provides cooling for the hot gases, so that is also one more advantages. But there are disadvantages also, like it produces wastewater, because air pollution is being converted into kind of water pollution. So you need to treat wastewater basically, right? And then there is corrosion problem, because acidic environment occurs due to SO2, etc. And then corrosion happens, so more operational cost may be there, right? When we talk about the gaseous pollution control from stationary sources, then we talk about three major principles like absorption, adsorption, and incineration or combustion basically. So depending upon the nature of the gas, we use any of these particular mechanism. So for adsorption, like activated carbon, etc., which have lot of porosity, so they adsorb these gases. And then activated carbon or zeolites or synthetic polymers may be there, silica gel. So again, depending upon which kind of gas you want to remove and which is a good adsorbent, you can use. But again, the issue is there that we have to regenerate it after some time, right? So adsorbent systems can be used for in different kind of systems, like fixed bed designs, moving bed designs, or fluidized bed designs. So industrial setup will decide which kind of design is needed. Then you can see these systems like non-regenerative, which use and you can throw it kind of thing is there. And like acid gases and organic compounds you can use for this particular mechanism. Then we come to the absorption. So in absorption, spray tower or packed bed absorber or spray tower absorber, tray tower absorber, venturi or ejector absorbers can be used again depending upon the industry. And acid gases and organic compounds can be removed. Plus biofiltration is also one way of removing these gases basically. So microorganisms, they derive energy out of those organic kind of material, and they remove those pollutants, right? And organic compounds can easily be removed by biofiltration. When we come to this mobile sources, basically we talk about emission control by like a engine exhaust or these fuel tank related carburetor related emissions we can talk about, like engine exhaust or this crankcase or fuel tank. So accordingly, devices also differ, and different pollutants are also different in that sense. Like in engine exhaust, you can see hydrocarbons, NOx, etc. And fuel tank, carburetor, etc. This hydrocarbon will be there. So exhaust gas recirculation can be there, or air injection system can be there. So you can see in these pictures, and in detail you can see afterwards. Otherwise, we have so many slides, so I will quickly just skip them. You can at leisure you can go through them, and we can discuss later on. But these are the devices, like air injection system is there for it can combine unburnt hydrocarbon, so efficiency increases basically. You don't waste much unburnt hydrocarbons, etc. So then there is this catalytic converter, which is fitted in exhaust pipe, and it is very widely used basically, and it can convert NOx emissions and CO emissions or hydrocarbons into carbon dioxide or this nitrogen and vapor, because these are the harmless gases which are in the atmosphere, as you know. Of course, CO2 and H2 are greenhouse gases, but as such they are not toxic, you can say. So these are the catalytic converters which are used. Then there may be in crankcase this kind of system where again you can collect the leaked combustion gases and you can again use for the burning purpose. Carburetor related emissions can also be collected and which can be used. And you can have these kind of systems where you can control these emissions from the fuel tank and carburetor. So in conclusion, we can say from air pollution control point of view that depending upon the source, whether it is a stationary source, point source, or mobile source, or whether it is a coal-based thermal power plant or some gas-based activity, depending upon what kind of pollutant we want to remove, whether it is particulate matter is more important to remove or gaseous pollutant. So accordingly, the device can be suggested to remove the pollutants. And we have seen that for particulate matter, ESPs are good, but high cost is there initially. Now we come to the second part, that is the sector-wise mitigation measures to control the air pollution, because we have different sectors of the emissions like transportation, domestic, industrial. So accordingly, we can have different policies, different programs which can help us to prevent or to mitigate those pollution streams or emissions. And when we talk about sectors, so like as I said, agriculture sector is there, power sector is there. We have already discussed about these sectors when we discussed about emission inventory, right? When we plan city, in fact, during the planning of the city, if you pay attention to zoning, like industrial zones are there, then green belt is there. So that way you can easily handle the situation and air quality deterioration can be avoided basically. And domestic emissions can be reduced drastically. Plus, like biomass burning can be these wood or cow dung, etc. They can be avoided if we supply LPG. So, like Pradhan Mantri Ujjwala Yojana is there, okay, and they are supplying LPG to poor segment of the population. So that way, they are also helping in reducing a lot of emissions in that premise or in that setup, because in kitchen in rural areas they use a lot of these wood, etc., and they are highly polluting because their burning process is not so good. But when LPG is used, then it's a cleaner fuel in comparison basically. Okay, then if we go for like solar lighting and like solar lantern or lamps, etc., then also it is good, because otherwise I remember in my childhood also we used to have these kerosene based lamps in houses. So those were quite polluting kind of light sources. So those are not good. And if you go for these solar lamps or electric lamps, then of course emissions can be drastically reduced. Then when we talk about like refuse burning or waste burning, if we can ban it, then it's a wonderful way of controlling the particulate matter emissions or other kind of toxic emissions also, because in our society we have this kind of a very peculiar habit that collect the waste and people just don't think and they just burn it. That's not good basically, right? So we have to collect them and if possible segregate and dispose it of properly. So those if you want to reduce those emissions which are from these refuse burning, we have to be careful. Maybe some policy measures can be there, some mobile applications can be used to inform the municipality that this is the place where a lot of refuse is dumped and it may be burnt after some time, or it is being burnt. Then they can come and take it away. Those kind of things. Waste to energy options. Let me share with you, like in the Lidköping city of Sweden, when I visited, I saw that complete city's public transportation system is based on the energy derived from the waste. Like they are having biogas from slaughterhouse waste, anaerobic digestion. They have steam propelled electric generation by burning other solid waste, and then warm water is circulated in the entire city. So that way, waste to energy options can be a good thing, and particularly in our country where we are the energy deficit country, so we should go for these kind of things. But this is only possible when we can segregate the waste at the source, and we can have a good calorific value where we can use that waste to have convert into the energy. And organic waste, then you can convert it into a this biogas. Well, when go for like you want to reduce the resuspended dust pollution, then we have to clean the road. So accordingly, we have to have this paved kind of roads, etc., so that we don't have chances of resuspension of the dust. Then you can use these kind of fogging system or other like sprinkle kind of thing, so that you can avoid the suspension of the dust, etc., at the particularly construction site. Well, when we talk about the transportation sector, then basically this avoid shift improve approach is very good. Like you can avoid travel demands when we are we don't have to travel. If we can have our meetings through online and those kind of things are there, so minimum possible travel can be done. Otherwise, you can avoid it. You can shift also, like from private to public transportation system, or from motorized to non-motorized transportation system, like bicycle, etc. Right? And then, if it is not possible to avoid those, fuel-based transportation system, then we can go for cleaner fuel, basically cleaner fuel-based transportation system. Then better planning can also be there, like travel demand management can be there. We can use this intelligent transportation system, so that congestion can be avoided, and public transportation can be used. And nowadays this TUD related planning is very much, so that you can have lot of demand can be met at a particular in a area. Okay. And as I said, non-motorized transportation system, like in European countries, they have very good infrastructure, dedicated lanes for them, and those kind of things we can think of, basically. Well, when we go for better fuel quality, so you can see in India we have gone in this direction, and like from 2003, when we had this auto fuel policy, we are going for cleaner and cleaner fuel. Like from BS4, now we are jumping to the BS6 already, right? So that is again one way of having very less emissions, because BS6 is a very good fuel quality, and per unit of fuel burning gives very less amount of pollutants. Then also we can go for like this inspection and maintenance programs, which is properly managed. And nowadays lot of apps are there, so those apps can be used to figure out whether this car needs to go to the garage, and those kind of things we can integrate. Also some schemes can be like odd even, so that you can reduce number of vehicles at the road, and congestion can be avoided. Otherwise, in congestion, lot of emissions comes because of slow speed and a lot of fuel burning. And there may be dedicated lanes for certain traffic. Those kind of things can be there. Well, bypasses can be there. As you can see in Delhi, you have this eastern periphery. So interstate vehicles don't go to Delhi. They want to go other states, so they just bypass it. So that way, with high speed you go, less emission is there. Plus, you don't need to go for for that city, basically, right? Then we go for like road to rail freight improvements. We are having corridors. Okay, so they will have high speed kind of these corridors, rail corridors, which will cater only the luggage and heavy duty kind of things, right? Also we can have these inland waterways. Bangladesh is catering around, I think, 20 to 30% of their these goods, etc., transportation, whereas in our country we are still, I think, below 5. So huge scope is there in inland waterways, and there is emission per unit of this load. If you calculate, very less amount of emission is there in inland waterways. So we can shift these goods transportation from highway to railway and railway to inland waterways. Those kind of things we can think of. Then electric mobility, lot of emphasis is there in our government. Even during budget, you might have noticed that this battery swapping kind of schemes are coming. So that will make quite easy for these electric driven battery based vehicles. And that way, this pollution which was coming from transportation sector, this will be drastically reduced, basically. Although people have different viewpoints also, like they say that if you generate electricity from transport, these power plants which are based on coal, then again pollution is there. But this is a tricky issue, because at least you are avoiding the emissions at the this site of the breathing level. So this health risk related issues may be drastically reduced when we go for electric driven vehicles. Then there will be issue of battery handling, etc., that we will manage, but at least the emissions of the transportation sector will go away, and we will have better air quality in cities. So electric mobility we have to go for, and we can generate different scenarios in emission inventory also, that let us say 20% of the transportation demand is met by electric vehicles, then how much emission reduction is there, you can easily calculate. Okay, then there may be vigilance and enforcement kind of standards which you can see, so that can be through digital technology, through new technology, we can easily implement those things. Cleaner fuels always welcome, because they are less in emissions. Well, when we talk about online monitoring in an industrial sector, basically they can go for like online monitoring, so that we can know how much emission is coming, or if some equipment is not working, then we can easily notice the high emissions, and we can timely address it, right? So in industrial sector, there are several ways of controlling these emissions. Then stack emission standards, if we implement properly, and if there are certain standards for other pollutants which are still coming up, if we bring those standards quite quickly, then we can control them very easily. And we can go for like these coal based power plants, we can shift to gas based power plants, or coal can be cleaned, and better kind of coal quality, better quality coal can be used, so that way. And ESPs which should be functional properly, and there should be kind of monitoring that this ESP is functioning or not, so that way we can go for controlling those emissions. Well, when we talk about agriculture activities, so like these agriculture waste burning problem is huge nowadays. So there are now startups are coming which can convert those waste into some useful product. So if farmers get some income out of that, then it would be easy to handle those waste. Otherwise, they quickly burn it, and that is not good for air quality, ambient air quality in the region. So maybe through Manrega scheme or Prime Minister's Employment Generation Program, if we can integrate those kind of institutional and local entrepreneurs with these schemes, then we can have better results, I think. So those are the issues. Plus these kind of conversion of agriculture waste into like which can be used, these pellets which can be used for burning in boilers, furnaces, etc., because these are compressed and their calorific value is enhanced in a nice way. Well, dedicated policies can be there, and depending upon R&D and practices of the agriculture, we can reduce those emissions. Then other mitigation strategies and measures may be there through monitoring network, or other policies are there related to biomass burning or open waste burning. So we can implement them to improve the air quality and to reduce the pollution. And CPCB and this is the particular this NCAP program. This will have a great impact over the years to reduce particulate pollution. Several things are coming in terms of policies and programs and technologies, and this is the part of this particular activity, that when you will have better equipped with the knowledge and skill, then you will be able to implement those technologies and programs in nice way, and you will reduce those emissions. So these are the ways to mitigate or prevent pollution from different sectors or sources which can be easily used. So these are the references which you can go in leisure. So this is all for in this session. Thank you very much again for your kind attention. Now we can go for question answer based or interaction based part of this particular session. Thank you. Over to you, please.